Okay, so let's look at kind of what's in a MIDI message. So all MIDI messages are pretty similar in the way that they're formatted. I'm going to simplify the actual data that's flowing in, but this is basically what it looks like. A note in message, or I should say a note on message, looks like this. It's a little packet, and there are 3 numbers in it. It's going to say it's going to look something like that. So in that case, the 3 numbers are the note number, the velocity, and the channel. Okay, so in this message, we have note number 60, that's middle C. So every note has a number, which is an interesting thing to think about because that means that MIDI doesn't know the difference between accidentals. So for example, note number 61 is going to be C sharp, but D flat is also note number 61. MIDI doesn't really care about enharmonic spellings or any of that stuff. It just cares about what note it is. So we have note number 60, and we have a velocity of 127. That's the top. That's as loud as we can get. And we have MIDI channel 1. Cool. So that's what a note on message looks like. A note off message looks like exactly the same. 60, 0, 1. So, and it works the same. Note number, velocity, channel. So this is saying play note number 60 at a velocity of 0. That's how we turn it off. And on channel 1. Cool. Now there are other kinds of messages that get sent in MIDI. In particular, control messages. Control messages work a little bit different, but the data is roughly the same. So a control message will look something like this. Actually, it'll look pretty similar. So when a control message comes, there's something that tells the computer that this is a control message versus a note message. But the guts of it, the numbers inside of it, are kind of the same. So the first thing is the controller number. The second thing is the value, and the third thing is the channel. So a controller would be something like the mod wheel on your keyboard, or any kind of button type thing that isn't going to send a note. So sliders, faders, any of that kind of stuff. Foot pedals are a good one. Any kind of a sustain pedal, something like that. So let's use a sustain pedal, for example. So each possible controller is assigned a number. So I don't remember what the number of a sustain pedal is, but it's standardized. So computers know that your keyboard sustain pedal is going to be controller number something because they always are. It's always the same. So let's say sustain pedal is 60. So 127 would mean its top value, so it's all the way down. And it's going to send on a channel also, so it's going to be on channel 1. Okay, and then we can do the same thing to turn those off. We can send it at a 0, although you don't need to turn controller messages off the same way notes do. You can just leave it at 127 if you want. So controller messages work a little bit differently, but they're the same basic thing. There are other kind of messages. Sometimes you see this written, sysx messages. Sysx is shortened for system exclusive, which is a fancy way to say it's proprietary to whatever weird keyboard you have. If you have a weird keyboard that does something weird, like it's got some contraption on it that no other keyboards have, then they need to find a way to send that into the computer. And the way that they'll do that is through a system exclusive message. It just means that there's no standard number for this thing I'm sending you. Like how our sustain pedal has a number assigned to it. That's always the same. System exclusive messages are unique to different keyboards, and those messages exist just so that a computer knows to do something with them. So that's basically how MIDI messages look if you were to kind of pop open the hood on them and dissect them.